Hello and welcome to DAO Codes. Today we're going to be diving into system design practice. Today we're going to be doing the Uber app, and then we're going to get into designing our custom AI model. So it's going to be super exciting. So we're going to hop right in. Let me just open up the necessary things for system design. And we'll get started. Okay. So we can see that. Beautiful. So today we are going to be doing Uber, like I said. Ooh. But I love when that do that. Okay, so, and if you guys don't know what Uber is, I think everyone does. It basically, the main part of the app we're going to be designing is how drivers can pick up, and then how drivers can, or how passengers can get picked up as well. So that's gonna be the main focus of today. And just let me make sure. So there we go. So let me go make sure I have my Visio diagram ready this time. Where did that go? So we'll get into creating a flowchart and all the things. Yes, UML diagram. I guess it closed out on me. So we'll just go to that. Okay. So to start, just like with Twitter, we're going to do our functional requirements. So we're just going to copy a lot of this stuff down. And non-functional requirements. And then we'll get into a little bit of the implementation. And we won't take as long doing that. And hopefully we can dive into some code quickly. Okay. So I think the biggest thing is going to be, this is Uber. Let's just close this down for a little bit. So what does the app do? So there's going to be two parts. There's going to be the driver experience, and there's going to be the passenger experience. So a passenger needs to be able to request a ride. And we're not going to get into car sizes. We're not going to get into like Uber Luxury or Uber XL, things like that. Just base request a ride. We need to be able to cancel a ride. And then we need to know if, and then pay. And we won't get too much into the way we pay. We're going to just assume you use some sort of service like Stripe, which is pretty common nowadays. And then what else? Maybe a during trip, view directions, and rate the driver after trip. Okay. Now the driver experience, you need to be able to add acceptance to a ride. You need to be enable taxi mode, start to accept rides in the area. You need to be able to message the, well, we won't do the messaging. We'll do that another time. So enable taxi mode and then disable taxi mode. You need to be able to, what else do you need to do? Accept the passenger. And that's all we'll do for now. Okay. So non-functional requirements. So Uber is actually a really interesting one because at the beginning they were not well architected. They used an MVP of just a simple front end and a simple back end. And it actually led to them being basically overburdened. They couldn't handle all the people that wanted to use the app. So the sorry about that. My cat hit the garbage can. Okay, sorry. So the team had to find a new way to scale, and they actually went to a service-oriented architecture. So each different service has its own kind of side of the app. So let's get into a little bit what this looks like. So the non-functional requirements. This is a highly available app. This is a write-heavy system. Constantly, the geolocation of the cab is changing, right? Because they are getting ready to take the next ride once they are, in service, ready to go. Constantly, geolocation is updating. Let's see. This is, maybe. Let's see. What is Uber numbers daily? How many rides? Each driver, Uber revenue and statistics. Sure. So they 156 million people once a month. Uber drivers completed 11.27 billion trips. That's actually insane. Okay, so 11.27 billion divided by 365, that's 308 million, I believe. Let's see, 300,000 or 800,000, 30 million rides a day on average over a year. 30 million, that's actually crazy. 30 million rides a day. So, and these are going to be highly concentrated in cities. Okay, so we could start just diving into what this looks like. So just like the Twitter one, let's pop over here. Let's pop over, like I said it here. Okay. That's not UML. Oh, did I just need to click the drive free? Yeah, I think I just did. So let's do file new. Okay. So we're really going to have two, and it could be the same app, right? It could be the same code, but it's really going to be two clients. We're going to have the drivers. And on the other side, we're going to have the passengers. Passengers. So basically, for everything, we're going to have two different things. And you could think of this as like a simple supply and demand, where you would have the supply app, which is the drivers, right? They're supplying the taxis that are required. And then the demand is supplying the users for it. And then we'll need some back-end asynchronous architecture to connect the supply and the demand, right? Super simple. That's a super simple highlight over what it is. So, right, so we're gonna have this API service out here. This is the passenger API. Oh my gosh, I cannot spell passenger. Passenger API. And we're gonna have the driver API. And these, these types of endpoints are gonna be like start accepting rides. That's going to take in a geolocation. It's going to take in a time. And then there's going to be a stop. And then also going to be like a driver ID. Stop accepting rides. This is going to be also an accept next ride, where it's going to be a single ride ID. Well, it's going to create a ride ID by having a user ID, driver ID, and a geolocation to and from. So that's going to be accept the user ride. Stop accepting rides, same thing. It's just going to be a time and a driver ID. Just basically say, I was Ubering from here to here. And we can get more into that as it goes. This one is going to be simple as request a ride. So this is going to be a user ID, a to and from location. What else? That's really gonna be it, honestly. And let's just make these boxes a little smaller. Not too much smaller though. Make sure they're still good. Okay, so at the end of the day, there needs to be some sort of asynchronous event handling to be able to say, I am accepting this ride because I've received a notification that there is a ride in my area, right? So it could go out to n number of drivers, and then it's the first one that accepts it. I actually don't know how the driver side of Uber works in terms of if it's sent out to multiple drivers. But we can say it's sent out to multiple drivers, because if it has to be sent out to one, wait for their response, it's gonna be a slower system, right? So it's basically here's a list of currently active. So maybe we go with that for now. So we know there's already gonna be some sort of queue, some sort of data hub that is holding the driver queue or the ride queue. And what this ride queue is going to be holding is the idea that there is a requested ride. So request a ride, basically enqueues a message here. This one is polling messages to the driver API. And I really don't like that it's doing that. And let's just go, boom. Let's just, can I just do straight? Straight. Okay. So request a ride, enqueues it. Enqueues ride request on, let's see. I don't know. I'm trying to think of the best way to say this. Enqueues on the data hub. And because geolocation is going to become a integral piece, right? Just because a user is requesting a ride in New York doesn't mean the drivers in San Francisco ever need to know about that. So a really simple way to do that is to connect the regions, like the geolocation IDs, and this is done by a Google service that's, the sphere is basically separated into chunks, and each has an ID, and that ID becomes the sharding key. And the idea in a database, when you have a geo replicated sharded database, is that there is many databases, and they only are able to, they're partitioned in a table, and basically all the information that has similar geo locations are going to be in the same area in the database. So when in San Francisco I need a ride, I don't look for data that's all over the place. I just look in the partition, which is faster just for me. It's not like I look at the whole database and then I filter down. It's I look specifically by partition key in the things around, right? If you need a larger area, it's going to take a longer time for things like cities. It's going to be a really small subset, right? There's going to be a lot of Uber drivers in New York City at one time, and also a lot of Uber requests. So you don't have to expand past the scope of the partition. It is all the exact same zone of like a 3-mile radius that has the same ID. So now your geo-replicated sharded database allows the lookups to be quick. So I have a demand. I put that into the ride queue. The ride queue asynchronously updates and writes the database. And the reason it does this asynchronously is because the process needs to be kicked off by events. So it's event-based, right? So drivers get a notification or get a new item in the list or whatever it is by event, and not just like hey, every 5 seconds, let's ping, right? Instead, it's a push system where I'm waiting for an event and I push onto you. So this could be like a Kafka, like an Azure Data Bus, or Azure Service Bus, Azure Queue. AWS has a version of this, I'm sure. Just the name is escaping me. AWS Queue. What is it? Is it literally called AQS? SQS, Simple Queue Service, right? So it's a messaging queue. So super simple that way. Does that make sense? So now once we have the passenger say, I request a ride, then this event comes out and says, okay, what drivers do I need to look? So now we're going to get a little bit of asynchronous compute out here. Pop. And this could be part of the driver API, but really it's async compute. And on event, on insert, on ride request, right? So it logically makes sense. You're going to say, oh, what are the closest Uber requests in my area? And obviously, some of the app does this a little differently where you are in the middle of requesting a ride and then it says, here are your options. Now you can pick different things. And this one's this far away and they have this rating. And a rating system is a whole different thing, right? Pretty simple scenario where a driver ID is connected to ratings of past rides. Not overly difficult to do. Right, that's just simple relational database stuff of you have ratings over here and then you have drivers over here and you just connect them up. Super simple. And then users are the ones creating the rating. So that's a super simple many to many, right? Where a driver can have many ratings and a user can give many ratings back. So super simple that way. But the harder part is getting those ride histories to be created. So you have an on ride request. So geo-replicated sharded database, you enqueue, there is a request to the ride queue, goes to the database, places the database. And this can be done, the API could also be putting in the database. You could also push it off to an asynchronous compute, same thing over here. But somehow from the queue gets placed in here. And really this is this is going to hold more data. The asynchronous compute is going to be from, this side of it, where it's, it fanned out. This is a fanned out thing. Scaled function in region. So, you're going to have all over the place these different computes. Let me zoom in just a little bit, make sure this makes sense. So yeah, we're getting there where we have now basically each region kind of has its own infrastructure, right? Because each region is going to be self-contained. You're not going to ever want data from a driver in San Francisco in the New York kind of Uber ecosystem, if that makes sense. So let's go back here. And let's just start doing some API endpoints. And so we have a lot of them kind of already documented, right? So from the passenger perspective, a passenger API. Oh my gosh, I cannot spell passenger. We're gonna have like request a ride and all these things. And actually, I was realizing we're going pretty long on this. When we first start out. So I'm just gonna pop this in there. And we are going to API diagram, and we'll continue on the Uber system design next time as we get further. But yeah, that's going to be a quick highlight over Uber and the way it's going to be connecting users to drivers. And it's all about supply and demand and how you match in the region the correct drivers to users. Okay, so let me just push this. Part 1 of Uber. Commit. Yes. Okay. So now we're going to get into some pretty fun stuff. We are going to be talking about the custom AI model at the center of DAO Breakpoint. So last time we finished up at least a semi-working version of, semi-working version of the auth. So auth now, you can log into users through Google, and you can't, just me, because I'm a test user. It's not actually out, and we need to do a lot more things to actually have a flow where you can complete a profile. But I wanted to move into some cool AI modeling stuff. And I've been thinking a lot about what that's going to look like. So if you look here, Did I close it already? I did. Create the login flow. Yep. So if I do open this back up, and one day I'll have Docker open. One day. Not today though. That the biggest thing is you now have a user and players are now connected to different things. But you still don't have an opportunity, and none of the infrastructure is built out to upload a video and have that result. Like what would even be that backend architecture? So let's actually open up some Paint. I'm just gonna do pretty high level stuff. Boom, 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 and boom. So this is the API, and we're not going to do the apps. The apps are pretty simple to do to get a video, right? It's just multi-form content. We'll have to do some thinking about what's the maxes and things like that, and that'll come when it comes. Let's just get rid of that. Let's open this up to be like a 20. Oh, come on. Yep, there we go. API. Let's move you right in the center. Okay. So we have an API. This is our input. So when this works, you get a video and it's going to upload to blob storage. Whoop. Well, I guess this one could be blob storage. And I want an arrow. And so uploads to blob storage. And I really, let's open just the UML stuff because I don't want to have to deal with this the entire time. And I promise we'll get to actual code instead of just UML diagramming today. Try for free. Why are you being like this? See, I know you could just do it. Why am I like on Atlassian? Okay, let's just get out of that. Don't want to have duplicated things there. Okay, so whatever. We don't need to talk. I can talk high level at it. We could actually get into it. So we'll upload a video to blob storage. Blob storage, at the same time, we get a request putting onto a queue. You then open up an asynchronous Azure function to then analyze the video. So we don't want to do this in process. We want to have this outside so we can be scalable and all those things. But the Azure function is going to load up, take the video, do the analysis work, and put the result in the database. But before we do that, we're going to have to write an AI service to do the analysis. And the way we're going to do that is a combination of a MoveNet, which is an ultra-fast, accurate model that detects 17 key points of a body. So taking a video with movement and turning it into numeric values, right? So let's see if it gives you some outputs. I thought I was looking at it earlier. Basically, it gives you an array where each of the different joints are a different index into the array, and it gives you the positions over time. So now you have a list of lists which correspond to your joints over time. So with those lists of lists, we would then move into Azure Custom ML. And what's called a CNN classifier. So it's a temporal convolutional network and forecasting. Dilated casual 1D with the same inputs and outputs. Right? Let's pop down to the bottom. All right, so it would handle at each layer what the classifying is going to do. So a pro tennis, what do their joints look like over time, basically? And then I give that a label of just the rating. And then we use a regressor to say which ones were the highest, basically what was responsible for the score, what was most responsible. So in a pro tennis serve, it's going to be 8 across the board. In my tennis serve, maybe, or a tennis stroke or whatever, I might get a 4-2. And my biggest difference between me and the pro, or the perfect and ideal, is my shoulder joints, right? It keeps identifying index 7, and I'm just making up the numbers, but index 7, which is my shoulder, which corresponds to my shoulder. So then I get 2 things out. I get what is my projected number from the TCN regressor, or TCN model, and then the regressor says what's relevant here. This is important because it allows us to then go into, okay, now we give it to just a straight LLM that has a prompt that says you are an expert tennis coach. This person has swung a 4-2, and their biggest difference between them and a pro swing was identified as their shoulder joints and their rotation. Please recommend 3 blah, 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 right? Give a prompt, give an output, give what we want to then make a tennis coach at the end. That's going to be our MVP. It's going to be MoveNet. So we get from video to numbers into a score, and then a score into tennis classification. So that is going to be our little model. And we're going to try and get a little bit further today and start doing that infrastructure. I'm going to have to do probably a little bit of offline just so we can actually move forward. Oh, here we go. Was I right? Elbow. The shoulder is 6. Bang. So close. I was looking at this. Yeah, and this one is just plotting it over time. But yeah, the way we're going to do this, I do not fully know. Because I know last time, this is going to be a fully separate thing. We have our analyzer function. We have our program. So we're going to have a C# Azure function to actually do it, but we're going to have to write some code to deploy our model and train it, right? Because just get this out of the way. Make sure we're over here on the side. Yep. The biggest thing there is how we are going to do the creation of the model, right? So that's gonna be a big thing. In the actual video analysis, we'll have to do MoveNet into input the values, the list of lists into the model, and then the model should regurgitate the score and stuff. But how to create that is going to be an interesting one. So let's just start prompting. That's going to be where we start today, is with some AI help to figure out what's actually going to be the way we do it. And yeah, so let's get into it. So let's pop over to a main branch. Get changes, pull you down, because I think we merged in our second branch already. Pull requests closed. Merged in. Yeah. Yep. Okay. So pulled you down. Let's open a new one. And let's do some planning. Let's open Visual Studio Code because I like my model in there better. No, not you. Open up. Got BreakPoint. Okay. Agent. Let's go architect. Let's actually go plan. So let's go analyzer service. Swing analyzer. Let's see sorry, just gotta. Okay. Sign in. No, I'm good. So I like to create a custom AI model to analyze a video of a tennis swing. My initial plan is to create a TCN model that takes MoveNet, the TensorFlow model, plus some heuristics from the data, and then does a temporal classifier over the time span, of the joint data. So a list of joint array data that corresponds to your joint position over time. Then that model would result in a tennis USTA score 1.0 to 7.0. Then I would use a regressor to determine which joints were most impactful in the decision, and then take that data plus the resulting score and give it to an LLM to determine some coaching tips. The UI UX for the user would be upload a video of a tennis swing, later come back, and once analyzed, the video would have MoveNet display the joints over time, and the caption would show some keyframes and the coaching feedback plus drills to improve. Okay, I would like you could also show a pro tennis swing of the same type and highlight the difference. Okay. Does this all make, and let's just go up. Does this all make sense? Please ask me any clarifying questions before we move on and plan an implementation. Let's ask some clarifying questions to better understand the scope and requirements for creating an implementation plan. Model training. Do you have access to labeled data sets of tennis swings with USTA ratings, or you need this to be created? What's your plan for obtaining ground truth data for? Are you planning to run MoveNet in inference client side or server side? This affects performance, privacy, and cost considerations. What video formats or resolutions are you targeting? Do you need real-time processing, or is batch processing acceptable? Where do you envision hosting the TCN endpoints? Yes, Azure ML endpoints. Are you focusing on general tennis strokes? Okay, so let's ask the for one. I will be creating the data sets. This is an MVP, so the data will be rather limited, but basically use pro swings as perfect 7/0 swings for easiness. Okay, 2. Are you planning to run MoveNet inference client side for the analysis of the swing that is going to be done asynchronous on the server side? So when you upload a video, it would upload the video to Azure Blob Storage, and then an Azure function kicks off, and the analysis starts. What video formats and resolutions? Not sure on formats, but could require normal formats and less than a minute, less than 30 seconds, less than a time. Okay, so 4, where do you envision hosting the TCN? Most likely an Azure ML endpoint, but the rest of the app is an Aspire app, so it will be containerized. Swing types. Are you focusing on general tennis swings or aiming for a general swing analysis? I will tag the data. Well, because it's a video analyzer, I was going to create models for each type. So backhand, forehand, and serve. For MVP, it might be a forehand and backhand. 6, professional comparison. How do you plan to source and store the process? Will these be pre-analyzed or processed on demand? This idea was a throwaway. This idea has not been thought out. Just an option, but most likely pre-analyzed. 7, user experience. Should you be able to immediately get or async is fine for now. Azure OpenAI would be the one most likely. Data storage. How do you want to store the process videos? Joint data. I see references to a player services related. 9, existing infrastructure. The Azure function app is going to be the async compute. The API is for the front end to be powered. And the data storage doesn't really matter. Perfect. Well, we got some context based existing code base. But my thought is if there is a way to run a TensorFlow in C#, then I would do that here. But most likely it's going to be another function app that is actually a Python function app that's hosted in a container that runs the MoveNet. So I get the MoveNet results, put that into the database, and calls the endpoint to upload it to Azure ML. So get the raw data, put it in a staging table of some sort, or otherwise just have it go straight into the thing and then never store that. Maybe that's what I do. Because the swing, the temporal data isn't overly impactful, if that makes sense. It's just a list of joints, and maybe that helps the video, right? You could just use that to show over time. I don't know, maybe. Oh, my desk is falling apart. I'll put that right there. Let me gather context myself. Understand what he's doing here. Reading existing codebase architecture. You read the DTOs, you read the proxy config, which isn't very helpful. Breakpoint services, breakpoint identity services. Perfect, now I have a concept of understanding. TL there. Extend the existing Azure-based architecture to support video upload, blob storage, Azure function, ML processing pipeline, move joint, extraction, TCN model scoring, LLM coaching feedback. Integrate with the existing player swing analysis models and add new video processing capabilities to the Angular front end. I don't want you to do all of that. Add video storage tracking to analysis event. Create video upload endpoints and player controller. Enhance swing analysis DTO with joint data and keyframes. Implement video processing pipeline. Create Azure blob storage and service collection. Implement MoveNet integration and joint extraction service. And build TCN model development wrapper for Azure ML endpoints. Set up Azure ML. Create TCN model training scripts for temporal joint classification. And implement model versioning and deployment automation. Create OpenAI integration service. Implement prompt engineering. Do you need real time, or is this? Do you want to train the TCL or set up Azure training pipelines, or how will you handle? Let's start with a very simple implementation of just the MoveNet because I need to get training data, basically. Let's start with a simple implementation of just the MoveNet to CNN or TCN so that I can, or of the MoveNet to TCN model training. I just want to see what that would look like. So a super simple, very simple implementation of just the MoveNet TCN model training. I just want to see what they'll look like. And then once I have something, I can see if it actually works with any efficacy. Great approach. Let's focus on the core ML pipeline first. MoveNet pose extraction to TCN model training. This will let you validate the concept before building out the full application integration. Yeah, so I can just drop files and stuff. Great focus plan for the MoveNet training pipeline. Searching code base. Okay, so that's fine. It's gonna be. Let me pop over here. Let's go issues. Because we're gonna start doing the AI work. Need to break down the stories into many. New chat response. Okay, so let's see. So perfect. Now I understand the concept. Let me see if okay. So TL there create a standalone Python training pipeline that processes tennis swing videos through MoveNet pose estimation, extracts temporal joint sequences, and trains a TCN to predict USTA scores. This MVP will validate the core ML concept before integrating with the full application. Add new folder with Python environment setup, requirements txt for TensorFlow MoveNet dependencies, separate directories for data processing, model training, and evaluation scripts. Implement MoveNet, create video processing pipeline using TensorFlow, extract 17 coordinates, and output as NumPy array with shapes for X, Y, and confidence. Design temporal convolutional network with dilated convolutions for sequence processing. Implement regression head for USTA scoring and add regularization / dropout for small data set handling. Develop video joint sequence preprocessor with frame sampling and normalization. Implement data augmentation. Create train validation scripts with cross validation for small data sets. Implement setup training loop with 4 add metrics, model checkpointing, and create evaluation scripts. TCN, what are these? If you better tasks for local patterns are important, while LSTMs are theoretically stronger for modeling very long term. Slower, more research. Recent shows often shows that 1D ends are designed to capture and remember information over long sequences. So I'm saying a TCN is a specific sophisticated architecture built upon 1D convolutional neural networks designed specifically for sequence modeling tasks like time analysis. The key difference lies in TCN's use of causal convolutions and dilated convolutions to handle temporal dependencies effectively. It's a type that applies filters across a single dimension, time steps in a sequence. It's primarily used to extract local patterns and dimensions from sequential data. Extends with specific constraints and features to make it more suitable where it performs causality, not inherently, but can use. See, the problem is it is causal. The swing at the beginning, what? Okay, I wanted to create the pipeline and then I can get data in the correct format. So decide on the models. Do you prefer MoveNet Lightning or Flow? Or we should test. For the analysis and training, let's do Thunder. For the web showing of it, let's do Lightning. What are your recommendations about 1D CNN instead of TCN? To me, a tennis swing has high causality with the previous frame. Does a 1D CNN work for that? You're absolutely right, the high causality. Tennis swings have strong temporal tendencies that favor TCN over 1D. Tennis swing is a kinetic chain where each joint's movement directly influences the next phase. TCN's dilated causal convolutions are specifically designed for this. The quality of contact point depends on the preparation 20 to 30 frames earlier. TCN's exponentially growing receptive fields capture these long-range patterns better than standard. Unlike general time series, tennis techniques require understanding the entire as a connected motion, not just local features. Okay, this gives you empirical validation, which works. Start with the infrastructure spoke about. Well, for simplicity, let's start with a 1D CNN. Can we also do some of this work in Azure? Jump board deployment to me, huh? Get banned. It was quite annoying when people do the fake things. Okay. Build using Azure ML and Azure Functions for inference. Create video, MoveNet, join sequences, USTA with blob storage. Setup, create in your resource group, configure connection for Aspire, add ML SDK to training environment with blob storage, integration for video data storage. Create video processing, build Azure Function or Azure LML pipeline for MoveNet pose extraction. Save join sequences, frame 17.2. To Azure Blob Storage as training data and create data, pre-processing scripts that normalize and augment joint sequences for model training. Create Azure ML training script with TensorFlow, design model with convolutional 1D layers, global max dense layers for UST regression, set up Azure ML, register trained in deploy to Azure, and update swing analyzer. Extend to handle, would you prefer or train locally and deploy? Let's do local training. I have a nice desktop here, and I want to iterate quickly. I also want to add extra. Hi, buddy. Add extra parameters to the MoveNet data. So not just joints, but also calculate some extra stuff based on the joints, like shoulder and hip rotation. Or is that unnecessary? Oh, and just to let you guys know, I do have to hop off at 6:50-ish today. I'm getting lunch with some family, so, or not lunch, dinner. What am I saying? Okay. Great plan. Those are key biomechanical indicators that coaches look for. Nice. Okay, add with... This is going to hurt the ML, the real ML people. Is there a way to do the ML pipeline in C#? Because then I can write it instead of having AI generate slop. Cons, no direct MoveNet support. Good for, but you'll still need Python TensorFlow for MoveNet. C# bindings for TensorFlow, less mature than Python TensorFlow, could potentially handle both. Loads excellent performance. Training still needs to be done elsewhere. Inference only. Train and deploy. Hybrid approach. Just do it all in C#. I was gonna say other things, but that's not string appropriate. We ball, you know? Excellent choice. Now, is it? It's probably the wrong choice. Create. Add new ML project. Feature engineering model training with GPU support configuration. Implement MoveNet integration in C#. Use TensorFlow Net to load pre-trained model. Thunder, create video extraction using OpenCV. Create video frame extraction and build pose estimation that outputs as C# arrays. So this is interesting. So create C# classes for calculating shoulder rotation, hip rotation, joint angles using vector math, implement joint velocity calculation, and design feature extraction that outputs structured data compatible with 1D CNN. Build convolutional neural network using TensorFlow Net, Keras API. Implement convolutional 1D global max pooling to dense layers for UST score regression and add training loop with loss function to metrics tracking in pure C#. Extend the swing analyzer service to include model training capabilities. Create data pipeline that works with existing analysis event workflow and add model persistence that integrates with Azure Blob Storage. Create model inference service that loads trained C# models, integrate with existing swing analyzer, and ensure seamless end-to-end C# pipeline for video upload. Okay, is less mature. Should we start and graduate Alex? Do you have CUDA? Ooh, do I have CUDA? I think I do. So question on step 2. Why do I need to take the TensorFlow? Well, why do I need to take video frame extraction to build pose estimation? aren't using all frames data over time as input. My input to my CD 1D CNN, sorry, would be something like list of joint key data extract joint data, where joint data is like int or double shoulder location, double knee, or left double right shoulder location, double shoulder rotation, etc. Because the keyframe is overcomplicated. Yes. Once you have that temporal sequence, flattened to a 2D tensor, 60 frames, 540 features. So you're right, the frame is just the pre-processing step to create your temporal joint sequence. The actual ML model only sees, not the individual frames. Use video frame extraction and MoveNet to convert into temporal and then feed this structured sequence directly into. Does this? Yes, it does. I want to do a lot of the supervised code. But yes, let's start. Just don't do it all at once. I want to make sure the model makes sense. Okay. Okay, so this is in Visual Studio Code, not. Add new. Okay, so I'm going to pull this off to the side. So basically, this is what we're going to be doing. I'm going to be doing probably a lot of this because I need to get the data, and we'll probably come back to it. And I might even end now so I can get ready for dinner. Yeah, it might be the move. Would you prefer to build this as a custom that integrate with your service later? Should we start with 4 to 6 key joints? Keep it simple or implement all 17. Do you have a sample data set we can use to test the frame extraction, or so we're simple test to validate the pipeline? Yeah, so I'm going to end it here for tonight. But this is going to be a lot of what we do next time. We'll do a lot of the C# pipelines together once I have the labeled data ready for us to do. I'll just get one of each level. So just 7 videos, super simple. And we'll build the services together. I just need to validate that this is going to be the way we want to do it. And maybe we can do a little bit of it now. We got some time. I don't want to cut it short. So add new console project, add TensorFlow. What is the industry standard way? I'm not an ML engineer at all. So industry standard way to do ML training. Because I imagine it's going to be data cleaning. Is it in GitHub just as a Python script? Like, what is the common way to do that? Is it professional but only Jupyter notebooks? Develop in Jupyter. Once it runs, find things or patterns, make these function in utils py, take a non-generational, move them to my project. Got it. Okay, so it is strictly just a thing. Okay. Yeah, interesting. And that makes sense. I knew we wouldn't put it there. Yeah, so I'm gonna end it here. Appreciate you guys stopping by. Hopefully this all made sense. This is kind of my thought process that I've having over the past couple days is, just up in the air. I kind of think this is how I want it, but this all makes sense that we're gonna actually create a console script to do, or a console application to do this thing, and upload videos. Once we have this bottom step of new console project, add the TensorFlow Net package, which I know ML engineers are going to hate me, real ones, but I want to do this in C#. That's what I know. And we also get to integrate with all our other services here. And then the joint data class is going to be super simple. This one's going to be a lot of POCOs. We can throw some tests on this one. How do you calculate a joint angle and things like that? Service to extract frames, implement basic frame sampling, and add simple. Ensure we can read tennis swing videos properly. Still don't need to do this, but thanks for trying to add that in, bro. Because once you have this, you just send it to the ML endpoint. Correct? Am I not? Using implement basic frame sampling and add simple video loading validation to ensure we can read tennis videos. Should we start with 4 to 6? Keep it simpler, but all 17. Do we have sample tennis videos? These are going to be some good questions. We're not going to use all 17 because if you look at MoveNet, oh, come on, where did it go now? There it goes. These are important. These are not so important. Important. So it's gonna be 15 out of the 17. So that'll be pretty cool to get into. And I might get a little ahead of myself and start doing it just to see what that would look like. And then we can go through the steps of how I did it. Because I think there's going to be a lot of decision making on, okay, where did this file live? Okay, let's get the data. And that's going to be all kind of boring stuff to do. And you're going to take longer than 2 hours. So yeah, thank you for stopping by if you did. This has been DAO Codes, and happy coding.